Hey guys, for this video we're going to be looking at specific heat and a worked example, and in the next one we'll be looking at latent heat. But for now, let's look at this definition. Right, specific heat is the amount of energy needed to raise the temperature of 1 kilogram of a substance by 1 degrees Kelvin or 1 degree Celsius. They're essentially the same thing. And we use specific heat in this formula, which relates Q, as in the heat transfer or heat energy transfer, which is equal to the mass of a substance times the specific heat times the change in temperature. Just quickly, the heat transfer will be in joules, which means that as mass is in kilograms and temperature is in degrees C, to make sure that when we multiply the 3 we get joules. Specific heat is given in joules per kilogram dot degrees C. Right, so let's look at how we use this formula in an example. Right, so we've got an example here. A 245.7 gram sample of metal at 75.2 degrees Celsius was placed in a 115.43 grams of water at 22 degrees Celsius. The final temperature of the water and metal was 34 degrees C, so they reached that thermal equilibrium. If no heat was lost to the surroundings, what is the specific heat of the metal? Well, what that final line tells us is that all the heat that moves out of the metal, we can assume that heat moves from the metal to the water because the metal is hotter, so all that heat energy that moves out of the metal must move into the water because that's the only place it can go. It can't go to the surroundings. Right, so that leads to this equation where all the heat leaving the metal, we use a minus because it's leaving, goes into the water. And just as a side note, you'll usually be given this on a formula sheet, but the specific heat of water is actually equal to 4.185 joules per kilogram dot degrees C. And we'll need that in just a moment. But what's important is that you can identify this concept, that all the heat leaving the metal, the only place it can go is into the water. Right, so we have equations for both of these. Mass of metal, C difference in T, so that's the one we just figured out, or we just learned a moment ago, and it's the same for this side. Mass of water, C of water, change in temperature of water, and that's the change in temperature of the metal. Right, so we can now just substitute in all our values. So we've got minus 0. The mass was 245.7, so we'll change that into kilograms. 0.2457. We've got the specific heat, which is what we're trying to find, and the change in temperature, well, it started at 75.2 and it finished at 34.6. So that's our change in temperature. On this side, we've got the mass of water as 0.11543 kilograms. We've got the specific heat of water as 4.185 times 10 to the 3. Sorry, I forgot to put that in up there. That's actually times 10 to the 3. This is, if that wasn't there, it'd be joules per gram dot degrees C. So we have to change that into kilograms by timing it by 10 to the 3. And the difference in temperature, well, the water started at 22.6 and finished at 34.6. So you can see you're going to get a negative number on this side, which will cancel out that negative on this side. So I'm going to stop worrying about negatives for this next line. Put that all in your calculator, you end up with 9.97542 cm. So times the specific heat of metal is equal to, put all that in your calculator, 579 96.89, and we simply divide by that number and we end up with cm equals 584.11 joules per kilogram degrees C, and that's how we solve for the specific heat of the metal. But most importantly, what to take out of this video is this line over here, that all the heat leaving the metal went into the water, because that'll help us solve any problems like this. And that concludes this lesson. Thanks, guys.